What can you tell me that you remember about solving equations? What do you remember about solving equations?
Like terms?
Okay, yep, you got to combine some like terms.
Do they have variables? I can't remember.
You do have variables. Okay, so the thing that makes an equation is that it's got an equal sign. Okay, we do have variables. And what are we doing? What do we have to do with that variable?
Are we solving for that variable?
We are solving for that variable. Okay? So that is our goal. When we are solving equations, we are finding the value of the variable. That's what we want to do. And the way that we do that is we isolate the variable. That is ultimately what we are deciding to do. We want to isolate that variable. Now, how many of you have siblings? Okay. I call this next part the sibling rule. And the reason that I call it the sibling rule is I have 2 children. I love my children dearly. Sometimes they drive me crazy. Okay? When my daughter turned 16, she got certain privileges. She got a curfew that was like 11. She got an allowance because she had big gas in her car. And she was able to make some decisions on her own. So when my son turned 16, what do you think he expected? He wanted all that same stuff. You're absolutely right. Okay? And so that's what happens. So if you've got a sibling, you expect your parents to spend the same amount of money on you at Christmas. You expect them to give you the same curfew based on your age. Okay? If they buy one of them a car, you expect to get a car too. Okay? I don't think any parents should buy their children's car, but just put that out there. But we do expect to be treated the same. That's the rule when you're solving equations. Do the same thing to both sides. So if I add something to both sides, or if I add something to one side, I've got to add it to the other. If I subtract something from one side, I've got to subtract it from the other. Multiply, both. Division, both. So you've got to do the exact same thing to both sides. That's the rule. Now, we solve equations by using something called inverse operations. Inverse operations are operations that undo each other. Does anybody know an example of an inverse operation?
Like adding 5 and subtracting 5?
Absolutely. Addition and subtraction are inverse operations. Okay? So if I've got a plus 5, I get rid of it by subtracting 5. If I have a negative 5, I get rid of it by adding 5. And I have to do that to both sides. If addition and subtraction are inverse operations, what's another set of inverse operations? Good. Multiplication and division. Now, I will tell you that square root and squaring, those are inverse operations, but we're not going to use that for a while. That's going to be down the line. Square root and squaring. Okay? And we use that very minimal. What I want us to focus on are the add, subtract, and the multiplying and the dividing. That's what we're going to focus on today. Okay, are we ready to get started? Okay. Here we go. Here is our first equation. So our goal here is that we want to isolate the x. We want to get the x by itself. So the way that we do that is we've got to get rid of the negative 1 first. So I add positive 1 to both sides. And when I add positive 1 to both sides, what happens to that negative 1? Disappears. Okay? So plus 1 and negative 1 simplify out. And I'm left with 2x equals 14. What operation is happening between that 2 and the x? Multiplication. How do I undo multiplication? Very good. Okay, and so x equals 7. Now, we are not going to check all of them just for the sake of time today, but I do want you to be aware of how to check. So the way that we check an equation is we take that 7 and we plug it in wherever there's an x. So I have 2 times 7 minus 1 equals 13. 2 times 7 is 14. 14 minus 1 is 13. So I got a true statement there. Because I got a true statement there, that means that x equals 7 is correct. What if I did not get a true statement there?
Did you answer wrong?
Then something's wrong. You got to go back and figure out where it's wrong. Okay? Now, let's move to the next one. Here we go. Negative 7 equals negative 5a plus 9. Negative 7 equals negative 5a plus 9. Okay? So what I want to do here is I still want to get the variable alone, but the variable's on the other side. And that's okay. Now you will hear me say, move your variable to the left, move your variable to the left. But if it's on the right, it doesn't make your answer wrong. Moving your variable to the left is just a good technique to get into for when we do inequalities. It's much more important when we do inequalities, and this is not an inequality. So what I'm going to do here is I'm going to subtract 9 from both sides. I subtract 9 from both sides. I get negative 16 equals negative 5a. My next step then is to divide by negative 5. Okay. What is negative over a negative? Positive. So my negative 16 over negative 5 becomes 16 over 5. Becomes 16 over 5. Now, that is an improper fraction, but that is okay. It's okay to have an improper fraction here. Okay? It's okay to have an improper fraction. So now, I'm going to go ahead and check this one too because we've got a fraction in it. So I've got negative 7 equals negative 5 over 1. Okay? Any integer, if it doesn't have a denominator, it's over 1. Negative 5 divided by 1 is negative 5. So I haven't changed the value. I've just put it over 1. Times 16 over 5 plus 9. Now, don't lose this negative right there. That negative's in front of the 5, but these 5s cancel out. So instead of having negative 5 here, what I have is negative 1. Okay? The 5s cancel out, but that negative is still there. So, now I've got negative 7 equals negative 1 times 16 plus 9. Okay? Does that work? Yes, it does. Is it okay to go to the next one? Okay. Our next problem here has variables on the same side, or on both sides. Has variables on both sides of the equal sign. What you need to do here is this is where you want to get in the habit of moving the variable to the left. Moving your variable to the left. Okay? So the first thing that I'm going to do here is get the variables on same side. And when I say the same side, I'm talking about the same side of the equal sign. Okay? So the way that I'm going to do that is I'm going to take 5x, and I'm going to subtract 5x from it. And this is a good opportunity to start moving things to the left because of inequalities. You could have subtracted 7x from both sides, but getting in that habit of moving it to the left is helpful. Okay? So I'm going to subtract 5x from both sides. And I'm left with 2x minus 3 equals 9. Okay? So in this case, the next thing that I want to focus on is moving numbers to other side. Okay? So I'm going to move numbers to the other side. Okay? So I'm going to get rid of this minus 3. How do I get rid of minus 3? I add 3. Good. Okay? So now I've got 2x equals 12. I divide both sides by 2. And what's my x value? Good. X equals 6. Okay? Most of the time, this kind of comes back. Once we throw fractions in, students get a little bit more confused. But a lot of times, people remember this from high school. Okay? Can I throw in distributive property? Okay. So, here we go. Here we have one that's a distributive property. So, the very first thing that we're going to do is we are going to distribute. Yeah, I knew that was going to happen. Trying to write it up too high. Okay. We are going to distribute. And we have to distribute several times. How many times do we have to distribute? 3. So that's what we're going to do first. We are going to distribute each one of these numbers. Okay. So I'm going to distribute the 4 to both of these. So I have 4y minus 4. And if you missed something on the prep assessment, sometimes it was that you didn't distribute to that second number. That 4 has to be multiplied by everything inside that parenthesis. Okay? Now, the next one I'm distributing 5. I'm going to say 5 times y and 5 times 2. 3 times y and 3 times negative 8. Okay? Okay. The second step in solving a problem like this is you are going to combine like terms on same side of equal sign. Okay? So what that means is I am going to combine this 4y and that 5y because they're all on the left-hand side of the equal sign. Okay? So 4y plus 5y. Okay? I'm going to combine that. What's 4y plus 5y? 9y. So I have 4y and 5y. Now, I have another set of like terms. What's my other set of like terms? Negative 4 and 10. Okay? Those are like terms. Negative 4 plus 10 is 6. So I have 3y minus 24. Now, my next step is to move the variable. Okay, that's my next step. So the way that I'm going to move that variable is I'm going to subtract 3y from both sides. Okay, so I have 6y plus 6 equals negative 24. Okay, and we know how to solve from here. Okay, I'm going to subtract 6 from both sides. I end up with 6y equals negative 30. I divide both sides by 6. And my final answer here is y equals -5. Okay? Now we are going to introduce denominators. We're going to introduce denominators. Can I move to the next screen? Okay. So, what we have here, or we have fractions. We have 1/2 x plus 2/3 equals 3/4. Now, because we're adding some fractions here, some students immediately think, okay, I have to find a common denominator. And I would agree that you have to find a common denominator. That is true. You have to find a common denominator. Okay? But we're going to treat it differently than we did when we were just adding fractions together, like we did on the prep assessment. Okay? What students might want to do, and this is a reasonable way to do it, it's just not the quickest and the easiest. What's my common denominator here? 12. Okay? 2, 3, and 4 all go into 12. That's my common denominator. So students might, and this is an option, this isn't incorrect mathematically, students might change all of these to common denominators. Okay? Then we can subtract 8/12 from both sides. Then we're going to have to divide by fractions. Okay? That is an okay way to do it. However, a better way to do it, and this is possible because we have an equal sign. If we are just adding fractions together, this is not possible. This is possible because we have an equal sign. What you are going to do is you are going to find your LCD. Okay, and we've already decided that our LCD here is 12. Then we are going to multiply all terms by the LCD. This step right here eliminates all denominators. And that's what you want to do. You want to eliminate all denominators. It makes it easier to do. Okay? So what I'm going to do is I am multiplying all of these by 12 over 1. By 12 over 1. So I've got 12 over 1 times 1/2 x. Then I've got 12 over 1 times 2/3. And then I've got 12 over 1 times 3/4. So in the purple, I have all of my original equation. And in the blue, I am multiplying each one of those by my LCD. Okay? Now my third step is to simplify. And when I simplify, all denominators should simplify out, and we'll have 1 in each of the denominators. So I want you to look at your 12 and your 2. In my first term, 12 and 2, what goes into both 12 and 2? 2. 6 is the answer. 2 is, no, you're fine. You're totally fine. I get that all the time. Your brain is one step ahead of us, and that's okay. 2 is what goes into both of them. 2 goes into 2 1 time, and 2 goes into 12 6 times. Now I am going to multiply 6 times 1 times x. Okay? And a lot of times that step right there, students skip. And that's fine if you skip that step, the 6 times 1 times x. Okay? What goes into 12 and 3? 3. 3 goes into 3 1 time. 3 goes into 12 4 times. So now I have 4 times 2. So I get the 4 from how many times 3 goes into 12, and then my 2 is right here. So I've got 4 times 2. Okay? 4 goes into 4 one time. 4 goes into 12 3 times. So I have 3 times 3. Okay? And again, this step right here, I'm showing you the math. If you skip that step, you're fine. Okay? Now, we solve the equation. But realize in step 3, you should eliminate all your denominators. Okay. So I am going to subtract 8 from both sides. I'm left with 6x equals 1. And my final answer is 1/6.
When I was solving it by myself, I got 6, but I guess because I didn't do it this way, I didn't get the fraction of the number 6.
Did you do 6 over 12 x plus?
Well, the way I did it is I did, wait, okay, yeah, so I made 2 over 3 negative. I went on ahead and brought it onto the other side.
Okay.
And I knew that 12 was the LCD, and I just kind of went from there.
Okay, if you got 6, there's a mistake somewhere. Okay, so let me see what you did, because that way.
I already erased it.
Okay, sorry.
And because when I decided to erase it because I wasn't sure if it was right, so I just ended up following that.
Gotcha. Yeah, you would still get 1/6, even if you did it the other way. You would still get 1/6. Okay. Can I go to the next one? Okay. Here, we definitely have what we call rational expressions, okay? They're very, very similar to fractions, and we're going to treat them a lot the same. But what I want you to do first is I want you to start thinking about that x minus 2 and that x plus 1 as a unit, okay? That is a binomial. And as we factor and as we simplify rationals and as we do all those things, that's going to be super important. So go ahead and get in the habit of putting parentheses around these numerators, okay? So that in your brain, you can start associating x minus 2 as a unit. And that's called a binomial, and that's chapter 3. But you want to start associating them that way. Now, again, we are going to find our LCD. Now, my denominators are 3, 8, and 6. 3, 8, and 6. One way that students will find least common denominators, because you may not be able to look at those 3 numbers and say, oh, I know what the LCD is. It is 4. Okay? So sometimes students will multiply 3 times 8, which is 24, times 6, which is 196. So you can always multiply all your denominators together, but you may get a very large common denominator that, and anytime we start working with bigger numbers, that's more opportunity for mistake. So what I would encourage you to do is a lot of times you can look at it. Like last time we could look at it and we knew it was 12. You may not be able to look at this one and say, oh, that's 24. You might not be able to. So here is a trick. Let me tell you what to do. Of 3, 8, and 6, what's my largest number? 8. 8 is my largest number. Okay? So what I'm going to do is I'm going to write down multiples of 8. What's 8 times 1? Okay? Do 3 and 6 go into 8? No. What's 8 times 2? 16. Do 3 and 6 go into 16? No. Okay? They don't go into it. Neither one of them do. What's 3 times 8? 24. Do 3 and 6 go into 24? Yes. Okay? So if you start writing out your multiples of one of the numbers, that's a good way to try and figure out which one's your least common denominator, because you want to work with as small a number as you can. Okay, again, we are going to do the same thing. we are going to multiply all of this by our LCD, which is 24 over 1. Okay, so I have 24 over 1 times x minus 2. And you will be glad that you have that in parentheses. Plus 24 over 1 times x plus 1 over 8. Then I have 24 over 1 times 5 over 6. Okay? Now our next step is to simplify. We're going to cross cancel. That's what we're doing there. It's called cross canceling. Okay? 3 goes into 3 and 24. 3 goes into 24 8 times. 3 goes into 3 1 time. This 8 is being multiplied by all of x minus 2. Okay? It's being multiplied by all of that. So you are going to have to distribute that 8 in our next step. Okay? 8 goes into 8 and 24. 8 goes into 8 1 time. 8 goes into 24 3 times. And again, you are going to have to distribute that 3. That's why it's a good idea to go ahead and put those in parentheses. Okay? 24 and 6. 6 goes into both of those. 6 goes into 6 once. 6 goes into 24 4. Then I have 4 times 5. Okay? Now you know how to solve this. I'm going to give you 3 minutes to solve it. So what do we have to do first? Okay, we can't do like terms yet.
Sorry,
Distribute. Before we do like terms, we got to distribute. So I have 8x minus 16, 3x plus 3 equals 20. Okay? Now I combine like terms.
11x.
Okay? I've got 8x and 3x. Those are my like terms, so I get 11x. Negative 16 plus 3, what do I get?
Minus 13.
Good. Okay, I add 13 to both sides.
11x is equal
Excellent. 11x equals 33.
to x is equal to 32.
Divide both sides by 11. X is equal to 3. Okay, how'd we do?
Got it right.
Yay! Okay. I know, I'm excited. That's good. Okay. Now we are going to use this principle and we're going to solve a subtraction problem. Okay? We're going to use all of these principles and we're going to solve one that's subtraction. Now, I want you to look at this one. It's 3t minus 1 minus t minus 4. Now go ahead and put your parentheses around your numerator. Okay, go ahead and put your parentheses around your numerator. Okay, that's important. But do you see that minus sign? If I had 3 minus 4, could I rewrite that as 3 plus negative 4? Yes, 3 minus 4 and 3 plus negative 4 are the same thing. If I had 1/2 minus 2/3, could I rewrite that as 1/2 plus negative 2/3? Yes, you can. So what I did with the 1/2 plus negative 2/3, that's what I want you to do with this minus in between my two terms. And the reason for that is that minus sign belongs to all of t minus 4, and we're going to have to distribute that negative. If you don't move that negative to the numerator, you are likely going to forget it exists. Okay? So the very first thing that I want you to do in this problem right here is I want you to change this minus to a plus, and I want you to put a negative right here. Now, what number could I put with that negative? A 1. Okay, so this is essentially, I'm multiplying all of this by negative 1. Okay? That is going to help you not forget your negative. Okay. Now I still need my LCD. What's my LCD? 15. Okay? 5 and 3 is typically one you can look at and realize what your LCD is. So what I'm going to do now is I'm going to multiply everything times 15 over 1. So I have 15 over 1 times 3t minus 1 over 5 plus 15 over 1, and I'm going to write this as times negative 1 times t minus 4 over 3. And that equals 15 over 1 times 1. Okay? It's that negative 1 that sometimes confuses students. So go ahead and deal with it from the beginning. Give it a name. Give it a place. Don't have to deal with that minus and try to remember. Yes, Jennifer.
I don't know how to word it, but I like using this method better. How would I do it?
You would have to do 3t over 5 minus 1 over 5. Okay? And then you'd have to do minus t over 3 and then plus 4 over 3. Okay? And then you find your common denominator and go from there. Okay, and it's fine to do it that way. You may decide you don't want to do it that way, but it's fine. It's mathematically correct. so now I'm going to cancel out what I can cancel out. 5 goes into 5 one time. 5 goes into 15 3 times. So I am left with 3 times 3t minus 1. 3 goes into 3 one time. 3 goes into 15 5 times. So now I have 5 times negative 1 times t minus 4. Now, a lot of students, when they are at this step right here, will go ahead and say 5 times negative 1. What's 5 times negative 1? Negative 5. A lot of students don't write this right here down. And that's okay. You don't have to, as long as you've got a negative 5. So then I have 3 times 3t minus 1 minus 5, or plus negative 5. You can do it however you want. Okay? So now I've got 9t minus 3, negative 5t plus 20. And what happens if you don't deal with that negative from the beginning? You end up with minus 20 right there. That's where the mistake is if you don't deal with that negative 1. Okay? So now I've got negative 5t plus 9t. 4t. Negative 3 plus 20 is 17. I'm going to subtract 17 from both sides. I have 4t equals negative 2. Okay, I'm going right here. 4t equals negative 2. I divide both sides by 4. What's my final answer? Actually, 1/2. Negative 1/2. Okay? That's probably the most complex that you're going to do on your homework. So definitely practice those. I need to actually go back and make sure you got some negatives. Okay? Now I've got 2 more problems that we're going to do in the next 9 minutes. Okay, but this is probably the most complex. So don't hesitate to go back and watch this part of the video while you're working on these types of problems with your homework. And there's also videos. Look for the Watch Me in your homework. They have Watch Me videos in your homework. Okay. Now we're going to move to decimals. Decimals aren't really as scary as fractions, but we want to make sure we're solving them correctly. Now, just like I was able to eliminate all of my denominators, I'm also able to eliminate my decimals. You do not have to. If you are comfortable adding and subtracting decimals, go for it. Just remember, you do not have a calculator, but you certainly can add, subtract, multiply, and divide your decimals. You don't have to do this method. What I want you to look at is how many decimal spaces each one of those terms have. Okay? So my first term, how many decimal spaces does that have? 1. My second term, how many?
2.
How many for the third term?
2.
And the fourth? 2. Okay, so what's my highest number of decimal spaces? 2. Okay. If my highest number of decimal spaces is 1, then I am going to multiply everything by 10 to eliminate my decimal. Okay? If my highest number of decimal places is 2, I am going to multiply everything by 100 to eliminate my decimals. If my highest decimal place is 3, any guesses? 1,000. Okay, now, don't forget, you have to do exactly the same thing to both sides. So the fact that this one is 1 decimal place doesn't matter. You've got to multiply everything by the same number. So you always go with the highest decimal place. So what should I multiply all of this by? 100. Okay? Because that is the highest decimals place. So I'm going to multiply all of this by 100. Okay? So I have 100 times 0.2x plus 100 times 0.24 equals 100 times 0.08x plus 100 times 0.72. Okay? Now, when I multiply by 100, how many times do I move the decimal place? 2. Okay? So what am I going to put right there? I've moved it twice, but there's no number. So what do I put there? 0. So 0.2x multiplied by 100 becomes 20x. That's typically the one that students would make a mistake on right there, is that 0.2x. Here, I move it 2 spaces. I've got 24. Here, I move it 2 spaces. I get 8x. And then 72. And we know how to solve that. We know how to solve that. Okay, we're going to subtract 8x from both sides. Okay, so I'm left with 12x plus 24 equals 72. When I subtract 24 from each side, I'm left with 48. 48 divided by 12 is 4. Good. Good. Now, before I let you go, I need to show you one more thing. Okay?
Oh, wait. Well,
Okay. Can I move off this screen? Okay? You're fine. Okay. Now, this right here is what makes this one different. That's what makes this one different. But what is my highest number of decimals? 2. So what am I going to multiply everything by? 100. Okay? So I'm going to multiply all of this by 100. Now, if I had 2 times 4 times 3, 2 times 4 times 3, I would do 2 times 4 is what? 8. Then I would do 8 times 3. Okay? What if I had 2 times 3 times x minus 4? What would I do first? 2 and 3. I'd multiply 2 times 3 together, and I would get 6. And what would I distribute here? The 6. Okay? So, in this situation, I am multiplying 100 times everything here. Okay? But here, there we go. But here, because of how this is written, I just multiply the 1100ths times. Okay? So here I've got 100 times 0.12x. 100 times 0.12x, that's going to give me what? Good. I move it 2 spaces. Here, I multiply these two together. 100 times 0.11 is 11. Then it's the 11 that I distribute. I'm done with the 100. Once I multiply 100 times 0.11, I'm done. Okay? The only thing I'm distributing is the 11. So I have 12x. 11 times 7,000 is 7,700. Okay, and at this point, the problem's not too difficult to solve. It's that highlighted yellow part that students get confused. 12x minus 11x is 1x. And then my last step is going to be to subtract 77,000. What is 79,000 minus 77,000? 2,000. 2,000. Okay. If you did not pick up your prep assessment, I would encourage you to do that today. Okay, if you have not done your quiz 0, you can do it today, Monday, Tuesday, or Wednesday. Have a good weekend.